Hello everyone, welcome to our presentation. So before I start, I introduce myself and my teammates. So I am Lincoln Dotto and my ID is 241-15281. And my teammates are Fahim, Shakil, Nasima and Ritik. So today's our presentation topic is real life application of engineering mathematics. So before you want to know about engineering mathematics, we should know what is engineering mathematics. So engineering mathematics is the application of mathematical technique and methods to solve engineering problems in fields like physics, mechanical engineering, electrical engineering, etc. So the important topic of engineering mathematics are it provides essential tools to model, analyze and optimize real-world engineering system. It's curriculum for designing algorithms, optimizing system, predicting outcomes and ensuring efficiency. So structure engineering, civil engineering. So mathematical technique used, differential equation, linear algebra optimization applications are used in the design of buildings, bridges and dams to calculate structure, integrity, load distribution and material requirements. So some of examples are shown in the slide. So it's our use of matrix methods to analyze forces in trusses and beams for load distribution. So engineering mathematics is also used in finance, stock market analysis. So mathematical techniques used in stock market analysis are probability, statistics, differential equation. The application of engineering mathematics in stock market analysis are used in predict stock prices, risk management, and portfolio optimization. Mathematical models such as the Black-Scholes model are used for optimization pricing. So some of examples are shown in slide. So if example are using stock prices processing to model randomly movements in stock prices.
I am Fahim Shahriar Rizvi. My ID is 241-15610. Section 66M. Today I am talking about real life application of engineering mathematics like electrical engineering circuit design. Mathematical techniques which are used complex number, Laplace transformation, Fourier analysis application used in designing and analyzing electrical circuit control system and signal processing. Example, solving differential equations to model the response of electrical circuit like resistive, capacitive and inductive. Beside we can see some electrical circuit. For solving this circuit we need engineering mathematics formula. Medicine, medical imaging, mathematical techniques used. Fourier transformation, linear algebra, image reconstruction. Application, mathematical algorithms are used to reconstruct 3D images from MRI or CT scan data. Example, using Fourier transformation to analyze and reconstruct images from raw data in medical scan. Beside we can see some engineering mathematics formula. By using this formula we can find out the MRI and CT scan data. Mechanical engineering, fluid dynamics, mathematical techniques used. Partial differentiation equation, numerical method, computational fluid dynamics CFD application used to simulate airflow in aircraft, design pumps, turbines and understand the fluid behavior in various systems. Example, using Navier-Stokes equation to model airflow over an aircraft wing and calculate aerodynamic forces. We can see some formula. By using this formula we can find out the behavior of a system. Epidemiology, disease spread modeling, mathematical techniques used. Differential equation, statistics, probability theory application used to model the spread of disease in populations such as predicting the course of an epidemic. Example, SIR models are used to predict how disease like flu, COVID-19 spread. Beside we can see some graph. By solving this graph we can predict how disease spread. Chemical engineering, reaction kinetics, mathematical techniques used. Differential equation, stoichiometry optimization. Application used to model chemical reaction and optimize reaction rate in reactor. Example, using rate law differential equation to model the concentration of reactants and product in chemical reaction. Beside we can see some formula. By using this formula we can know the reaction rate and optimize reaction rate in reactors. Thank you, ma'am. Assalamu.
Hello everyone, my name is Shakil Ahmed Hridoy. My ID is 241-15392. Today I will explain the real-life applications of engineering mathematics. I will cover examples from computer science, aerospace engineering, and cryptography, and environmental engineering. In computer science, algorithms and data structure. In computer science, mathematical techniques like discrete mathematics, graph theory, combinatorics, and complexity theory are used. These techniques help us develop algorithms for tasks like sorting, searching, and optimization. Example, graph theory is used in Dijkstra algorithms to find the shortest path in network routing. Aerospace engineering, flight dynamics. In aerospace engineering, we use differential equations, metric methods, and numerical simulations. These help us simulate aircraft motion and study stability and control systems during flight. Example, equations of motion are used to calculate an aircraft's trajectory under different flying conditions. According to Newton's second law, force equals mass times acceleration. F is equal to ma. Cryptography. In cryptography, we apply number theory, modular arithmetic, and algebra. Mathematical algorithms are the backbone of modern cryptography, ensuring secure communication in online transactions. Example, the RSA encryption algorithm uses large prime numbers and modular arithmetic to securely encrypt data. Environmental engineering, pollution modeling. In environmental engineering, we use systems of equations, modeling techniques, differential equations, and statistics. These mathematical tools help model pollution in air, water, and soil and predict how pollutions spread. Example, we model how pollutants disappear in rivers or oceans using differential equations. Thank you, everyone.
My name is Ms. Nasima Khatun. My ID is last 3 digit 340. Today I am presenting my presentation. My presentation topic name is Real Life Application of Engineering Mathematics. Artificial Intelligence. Mathematical technique used in linear algebra, statistics, optimization, calculus. Application. Mathematical models form the backbone of machine learning algorithms used in AI applications like image recognition, natural language processing, and recommendation systems. For example, training a natural network using optimization algorithms like gradient descent. Biomedical engineering. Mathematical technique used in Fourier transforms, statistics, probability theory. Application in biomedical engineering used for reconstructing medical images like CT scans and MRI from raw data. For example, applying Fourier transforms to reconstruct a 3D MRI image from multiple 2D slides. Astronomy. Mathematical technique used in calculus, differential equation, Newton's law of motion. Application in astronomy used to predict the motion of celestial bodies, plan spacecraft trajectories, and understand the forces at play in planetary systems. For example, using Kepler's law and Newton's law of gravitation to calculate the orbit of a satellite. Control systems engineering. Mathematical techniques used in Laplace transforms, eigenvalues, matrix analysis. Application used to analyze and design feedback control systems, ensuring system stability and performance. For example, using the Routh-Hurwitz criterion to check the stability of a system's transform function. Thank you. I was ending my topic and I would call my next teammate Ritik Sarkar.
Hello everyone. Hello ma'am. Today in this presentation I am going to talk about the real life applications of engineering mathematics according to music. And my name is Ritik Sarkar. Today I am going to talk about the music segments and my ID number is 24115 948. So let's start. Actually, in this segment, I going to talk about the wave signals. The wave signals is actually worked in the visual side, the Microsoft Power BI. How this backend side works in this backend side is working by the Python and R language. In this visual side, we can use HTML and CSS by front end side. The next side is we can always use anytime the weather application or map, Google Map. How this Google Map and weather application works in, we can check the weather, how many days later the raining will start. Further, if we want to search any location by Google Map, it can be result in time by output. How this works in? This works in by like using backend side. This backend side is using linear algebra like BFS, DFS. It can search any type of variables. These variables is executed by locations. So it is the real life applications. The improves precision. Mathematical models allows engineers to predict real world behaviors with high accuracy. Surplus innovations. Engineering mathematics ensures innovation by providing mathematical framework for new technologies. So the summary is, in this last moment of our presentation, we acknowledged about the AI, ChatGPT, Grok AI, or etc. DeepSeek. These are using LLM. This LLM is executed by linear algebra like matrix, differentiation, integration, agency, breadth first, or graph theory. So thank you everyone.